All right, here we go.
Okay. So, I think that's it for coal for now. All right, good. All right, let's talk about oil. You're up, Will.
Oil. How we obtain it. We obtain oil by drilling into organic deposits formed 50 plus million years ago. We find underground reservoirs and we use oil wells to siphon the oil to the Earth's surface.
Okay, hold on. Drilling into oil wells trapped underground. Is that a good way to summarize it?
Yeah.
Before you continue, maybe you're going to get to it, but I want to write in our notes. What is the oil? Where did it come from?
What is oil?
What is it?
It's just like dead, isn't it dead animal? Pretty much. It's it's organic matter that's been liquefied.
Right, and actually, what's the name that we give it? Not just oil.
Crude oil? What do you?
Petroleum is technically what it's called, but crude oil, petroleum, right? Just make sure you guys know the terms there. So yeah, it's a fossil fuel from plants that have decayed.
Oh.
So oil is created from plants that have been fossilized, we'll say, for, what's the time frame for oil? So coal is like 300 million years.
I got 50 million or older.
Yeah, so I have from 50 million to 150 million, so around 100 million. If you can remember, 100 million for oil, 300 million for coal. Just know coal's a lot older. For 50 to 150 MYA million years ago. And specifically, what plants? I made a point to focus.
Ferns.
No, that's coal.
I don't know why. Why would I look up?
Phytoplankton.
No.
That wasn't one of the questions.
He did mention that though.
That's right. Phytoplankton. So ferns,
What is
responsible
that?
for coal. Phytoplankton is microscopic algae.
Is petroleum just another word for crude oil, or?
Yeah. So I have both definitions here. Do you have them?
No.
Okay.
Not for
So petroleum, widely used fossil fuel that occurs in underground deposits composed of liquid mixture of hydrocarbons, water, and sulfur. Crude oil is liquid petroleum removed from the ground. So
It's like lava magma.
it's like lava magma, right?
So petroleum though is not what it still has to be refined.
Yeah, you have to refine it and work. Yeah, I have a lot of notes on oil if you don't cover a lot, which is fine.
It
I'm
goes and
teaching
has
you
to be
not,
refined into there's different types.
Yeah,
of
yeah,
diesel.
yeah. You can carry on with what you have. Let me just move this up. All right. So we typically drill into oil wells trapped underground, created from plants, 50 to 150 million phytoplankton. All right. Continuing. Go ahead, Will. What else you got?
What's next? After it's refined, it's turned into a variety of different types, and then we burn oil to create steam to generate electricity, or we burn oil to power a lot of our forms of transportation, such as cars, and then we also use it to heat buildings.
Okay. So when we refine crude oil, what are we refining it into?
Usable. Well, we're pretty much separating the different parts of it.
Good. So can you just list one type of fuel?
There's gas.
Gasoline.
There's
So we
diesel,
refine crude oil to make gasoline.
Kerosene.
What else?
Kerosene.
Kerosene.
Dieseline. No, it's just diesel.
That was funny. I never heard that before.
Diesel?
It wasn't very funny.
I thought it was
I
funny.
regret saying it.
No, that was good time. What else? We drive on it.
Roads.
What's it made of? Asphalt. And I'll give you one here. Tar. Also. You need oil for plastic as well. A lot of plastic is made from oil, so there you go. We use plastic all the time for everything. But anyways, all right, good. So yes, refined crude oil, and I'm going to show you kind of how that's done. A picture of it. Gasoline, kerosene, diesel, asphalt, tar. Let's see here. And then we can use the oil to, what did you say? Besides, like, fuel.
Create steam to generate electricity.
Use oil to create heat, to make steam.
Or we burn it to create exhaust gases, which spin turbines to create electricity.
Okay, so use oil to create heat, to make steam, to turn turbines for electricity. I mean, it can be used for that. We don't use, US doesn't really use oil too much for that. Natural gas, coal are the biggest forms, nuclear as well. But it can be, it could be. Also, you can use oil just for heat. Like at your house, burn oil for heat. Okay, what else?
The pros are oil has a high energy density and it has a 93% refining efficiency rate.
So, pro. High energy content, you said?
Yes.
High energy content. And then what was the efficiency part?
93% efficient when refined.
So refined oil is 93% efficient?
Yes.
Alright.
And then negatives, oil is non-renewable.
Non-renewable.
And a big polluter. Is the other one. Of the air.
Solution. So does it provide or produce CO2?
Yes.
Yeah. Anything else?
No.
Okay.
What do you have?
Oh, I got a bunch of stuff. So I'm going to show you a picture here.
Yeah. Yeah. Cool.
Don't connect to my board.
Yeah.
Put my Clash of Clans up there. Live attack.
Okay. Here we go. So I found this online here. It's just a good image. It's one in your book, but so this is kind of how it works under the ground here. You have the yeah, I'll read it to you. It says it has source rock, it has water, permeable reservoir. So there's rocks where it's permeable that the oil can kind of get through, and then you have impermeable rock, which kind of seals it in. That's what you have to drill through. And then you have the surface. So you drill through, gas is almost always trapped with it, gas meaning natural gas. So when you're drilling for oil, a lot of times you'll see there has to be outlets for gas that is often just burned. So that's kind of in the way. So they have to get that out, drill down into the oil, and then the oil starts coming out, and then we can pump it in barrels. And
What about
so,
fracking?
so hydrofracking is used for gas, not oil typically.
Okay.
But I'll get to that. So that's just a good image, right? So you have these, so you keep going down the ground, you have rocks, you have some water trapped there, you also have permeable material that the oil can get through, then it gets trapped, because it can't go any further, gas is on top of it, and then you have impermeable rock. So that's what we're drilling through to get to the oil. I think that's all I have for that. What is this? Oh, what is this? Oh yeah, here we go. This picture here. Sorry. That's the flow chart. Yeah, let me zoom in here on this thing. Alright, so this is called called cracking. Can you guys see that? Kinda, hopefully. So you got your crude oil, you heat it up, and then you have these different levels in this big chamber at different temperatures. This is over 350, this is 240 to 350, 170 to 250 Celsius, 35 to 180. So this is the cooler temperatures, this is higher temperatures. Up here it says petroleum gas fraction, and it says gasoline, kerosene, diesel, residuum, I don't know what that is actually, fuel oil, asphalt. So when you crack crude oil, meaning you're heating it up, and it's like distillation, you have different boiling points and then condensing points, and that's how you trap different hydrocarbons, because gasoline, mostly octane, has 8 carbons in it. I forget what kerosene and diesel fuel are, but if you remember in chemistry, the longer the chain, the higher the boiling point. Right, so the bigger the hydrocarbon, the hotter it has to be. So this kind of separates them based on size of hydrocarbon and boiling point, and that's how you refine it. And then you just isolate which one you want. Do you want kerosene, diesel, or gas? The good thing about oil is it's all in there. You just have to separate it. Fairly simple process once you have it set up. I mean, could we do it? No, but you know, there's people, this is what they do for a living, and this has been set up for a long time. So anyways, that's what, when he's talking about refining, that's what that is.
So if there's like oil and water and it like makes all the color and stuff, is it the different types of oils like being separated?
In the water,
Yeah.
I don't think some of a lot of these are.
You're talking about the rainbow?
Yeah.
No, I don't think you can't separate these unless you distill it.
Okay.
It's just it's a mixture, like a homogeneous mixture. Very difficult to separate that without some sort of phase change. Because there are probably differences in solubilities, but they're all non-polar, so none of them really dissolve in water. So, all right. So anyways, all right, back to this. Okay, so let's see. I got some other stuff here on oil, so I'm gonna keep moving this up here. All right. Was there another oil person?
Yeah, I don't know.
There's 4 people in this thing.
Let's just make sure we know the difference between petroleum and crude oil. So petroleum is a fossil fuel that occurs in underground deposits. Fossil fuel that is found in underground deposits. And it's a mixture of liquid hydrocarbons. What's a hydrocarbon?
Hydrogen and carbon.
Yep, just C's and H's, like octane, C8H18. Propane, C3H8. And then crude oil. Crude oil is petroleum removed from the ground. Petroleum removed from, wish this could go up higher, from the ground. Sorry, that's really messy. Alright. Good. Okay, can I kill this? Moving on. Emma, you good back there? Alright, put that up there. Okay, let's see, what did oil sands or tar sands? You know what, I might be doing too much work here. I think I have a PowerPoint here. Hold on, please. See. I'm gonna do the PowerPoint when I'm done. gonna keep giving you some more notes, then we'll go to the PowerPoint for like all fossil fuels. So oil sand, tar sand, slow flowing, viscous deposits of bitumen mixed with sand, water, and clay. Slow flowing, viscous. What's that mean? Yeah, like maple syrup. Viscous deposits of bitumen, not sure how to say that, which is a mixture of sand, water, and clay. Sand, water, and clay. And essentially, here, I'll kind of rewrite this. You can write that, but I'm just going to add to it down here. So you got your bitumen, which has sand, water, and clay sometimes mixed in with it. Let me give you a better explanation. It's degraded petroleum that forms when petroleum migrates to the surface of Earth and is modified by bacteria. So I'll simplify that. It's degraded petroleum that has been modified by bacteria. So there's crazy bacteria all over the place. There's nitrogen fixing bacteria. There's bacteria that can, they don't need. Survive in space. Bacteria that they don't need any oxygen to do their business. There's bacteria that basically start to decompose petroleum. So there's all types of bacteria, and this is just an example of a different type of petroleum. It's kind of like significantly degraded from just regular petroleum. So this is not trapped. I didn't write that. It starts mixing with things that other petroleum doesn't mix with. Extracting this stuff here instead of conventional oil is more labor intensive, costs more, more energy must be put into the process, thus reducing the efficiency. So I'm I'm just gonna put here, this can be utilized as a fuel source, but it's really not efficient. Not efficient. Did I spell that right? I did not. What am I doing there? It's just a T. Not efficient, and produces more CO2. You're gonna need more machines, more labor intensive. So the energy put in to get it out and then use it, and it's degraded on top of it, it's almost not worth it. But it is a source of energy. It's a different type of oil. It's called oil sands or tar sands. Okay. Moving on. Natural gas, right? I'm up. That's me. Natural gas. Here we go. All right. I keep sliding this up because I'm hoping I can take a picture of this whole thing here. I don't know how it's going to work. I'm going to save it to files to see if it works. All right. Natural gas. Here we go. Natural gas is the cleanest fossil fuel. It still produces CO2, but it doesn't have any impurities like oil and coal. Not really. It's pretty much just pure. It's almost all CH4, methane. There's no SO2 or NOx emitted. So that's no as in the word no, not nitrogen oxide. That looks confusing. So pretty much you're just burning methane, not a whole lot of impurities. Produces 60% less CO2 than coal. 60% less CO2 than coal. Supplied using pipelines. I mean, so does oil. There's a lot of pipelines for oil as well, which I'm going to kind of summarize everything here in a little bit. But these pipelines make it very easy to use. So supplied using pipelines, so easy to use. I want to say half of homes in the United States use natural gas for heat. Hold on. We'll get to that in a second. That's it. That's all I want to say about it right now. I have a whole sheet here on pros and cons of all three. Just things that we don't have. I wanted to summarize it. Actually, no. You know what? Never mind. I'll get into this right now. Hydrofracking. Hydrologic fracking. What do you guys know about it already?
Like shale or
Pushes
something.
water into the ground and create cracks for the rocks.
High pressure water and chemicals are pounded into the ground, essentially, shot in the ground, and it breaks rock apart. Why do we want to do that?
So the gas.
Gas can come up, because we just saw the picture, gas is trapped, right? So, sending high pressure water and chemicals into the ground to break rock, to allow gas to escape.
What's the point of using chemicals as well as water if you're just breaking rock?
So the chemicals do a better job sometimes. And there's also propping agents used, which help keep the rocks open. So water can't do that. So you crack the rock, and sometimes the rock will kind of come back together. So that pressure and force, the earth holding everything together. So there's propping agents put in there as well, like maybe little beads I even read somewhere that get in between the cracks, and when the rock comes back together, it gets stuck, so gas can continue to escape. Also, some of these chemicals here, I have them right here. Yeah, I wrote just the chemicals sometimes do a better job than the water. That's all I found on that. Let's see here. Before I talk about so what's the positives of this? Salem, you with me? What's the positives of it?
You're getting that.
You're getting natural gas, right? Good. And we have a lot that we could use, so we're not going to rely on foreign oil, for example, right? So that's a positive. I'll talk about the negatives here in a second. Do you know how they find gas deposits?
Is it
It's not like a water diviner.
It's like
You know what those are?
It's like a truck. It's called a.
Yes, very good. You good? Hold on. Do you know what water diviners are?
Yeah.
They have those special sticks. They walk around. They can find where a well should be dug. Yeah, water witch. Yeah. I can't explain it, but it seems to work. It's wild.
What?
It's these sticks they walk around, and like when they're over an aquifer or a water source, the sticks do something, and these people are like, yep, there's water there, drill. They just walk around with these sticks. They find water.
It's such a fun job.
How's that work?
I don't know.
How's it?
I have no idea.
So
It's not science.
It's aliens. How
Um,
is it not science? Because it works. That means someone has to know something you don't.
sure, of course, someone knows something I don't, but I don't know what scientific principle could
Oh
explain
yeah,
that.
is it?
All right, what's the trucks?
I don't know. Some of it's called like a thumper or something.
Thumper truck, very good. Thumper trucks. What do they do?
It uses sonic waves to bounce off the deposits. and-
Seismic waves.
Those, yeah, those.
Created by the truck
Well, I couldn't remember. Shut up.
to find gas deposits, because the waves bounce back, and there's sensors that are put on the surface. So when the waves come back, they can figure out if there's gas there or not.
And that's what causes earthquakes.
So right, so when you have both fracking can also cause earthquakes, because you are sending high pressure liquid and breaking rock that shouldn't be broken, so things get unstable. And on top of it, you're thumping with these incredibly heavy trucks. Did I write down the weight of these things?
Can we like get picture one of these?
I did look it up. Hold on, let me finish this here. So yeah, they're purposefully slamming the ground, sending seismic shocks essentially, which can trigger earthquakes or faults. It can cause all types of problems. So that's part of the negative here. So I'm gonna list those in a second. But anyways, that's how they find the natural gas. And if it's near your house, I mean, that's not really cool either. So that's what dumper trucks do. Pretty interesting. So let's talk about the negatives of the con. The pros are you're getting natural gas out of the ground for energy. That's kind of the only pro. All right, negative. Trigger earthquakes. Trigger earthquakes. What else? What do you think those chemicals could do?
Cause problem.
Contaminate what?
The water.
Aquifers.
Right, aquifers, right. Contaminate groundwater. What else?
Isn't it like dangerous for like people?
Yeah, it can be. Not like coal.
Well, you're putting a hole in the ground, so.
Well, that, yeah, that's,
Fall down.
so there's that.
It uses like a lot of water.
Okay. I didn't write that, but I like that one. Use a lot of water. You guys ever try and capture gas before?
No.
You lose a lot.
Balloons.
It's almost impossible to catch all of it, or even half of it. In fact, in the book, online, I looked at different sources. Scientists have no idea or estimate, but they think significant amount of methane is lost when trying to capture it. So, CH4 released into the atmosphere. Why is that bad?
That's like the worst greenhouse gas.
Yes, 25, write this down. I found the number. 25 times better at absorbing infrared radiation than CO2. So essentially it's 25 times worse for greenhouse effect. 25 times the infrared absorbing power of CO2. That's a big problem. However, CH4 does not exist forever. Chemical reactions do eliminate it.
How do they trap the gas when it comes out?
You know, I actually didn't look into that. It's a good question. I mean, they put it in pipelines, but
So
as
do
far
they
as how
just-
they funnel it,
Yeah, like, so there's a hole, do they just put the pipeline like right on the top?
yeah, I mean, obviously there's something to catch it, but I don't know. That's a good question. After all the stuff I looked into, I never read
Because I
anything
feel
about
like
physically how they do
If
it.
they do it correctly and you just put like a giant cap on it that leads into a
Yeah,
pipe, not
but
much
I mean, you need to have access to it. So, you know, it sounds easy, but it's like oil spills. They happen all over, the place. So it's not as easy as it sounds. You know, say like that argument I got with Mr. Matthews. Nuclear power sounds like this is the best, unless
Doesn't work.
it doesn't work and you have radiation all over the place. Like, so there's always the, you know, what could happen. So it sounds like it's easy. So,
Created snakes with 2 heads.
all right.
They didn't create
Okay.
themselves.
Am I still active casting? How much time do I have?
Like 10 minutes.
Here we go. Here we go. All right. So,
Can we see a picture of the bumper trucks?
Respawn into sponge,
Yeah.
which is 20 times stronger than steel.
I thought you were gonna say they're like 6 hours.
that's tongue.
That's ridiculous. Do you hear how you sound?
You just said spider webs. Oh.
Now, are they always floats or
There's one.
are they guiders?
So that thing there, I assume is what
What
thumps. Makes you think of the rabbit and thumper.
I love Bambi.
All right, that was fun. Okay.
Very
Can you
interesting.
close one of your tabs?
No, sound like Kayla Hanlon. I always have a lot open for you guys to have different things going on. By the time she gets here, period 6, she's like, "Why do you always have so many openings?" Because I have all these different pictures and stuff. All right. So moving on, we did this. All right, so let's look and see what they have. Advantages of coal. So here's what I want you to put in your notes. Any pro or con for coal you don't have, let's write it down right now. Then we'll do oil, then we'll do natural gas, and then I want to talk about biofuels. All right, I know we're doing a lot. It's really unfortunate we're missing more people here. Alright, so we already went through a lot of it. I just really want to make sure so that you just crush any question on the test about energy and fuels. I think by the time we're done with this unit, we've talked about fossil fuels a lot, and we'll talk about renewable. I want you to feel confident that any energy question, you're good. You have information, so no matter what they ask, you'll feel prepared. Alright, so energy dense, plentiful, there's a ton of it. I read somewhere, I want to say 300 years. There's like 300 years left, at least. So that's a
like
lot.
not that long.
Well,
in the grand
I mean, it is and it isn't. I mean, some people thought it was like they're running out soon. Same thing with oil. We're not. There's a lot left. That doesn't mean we should use it. I don't think we should, but just saying that plentiful. Easy to exploit.
Humans are gonna be extinct by then.
What's that?
Humans are gonna be extinct by then.
Really? You think by?
I give us 150 years.
Well,
Not-
so by 2050.
Kids.
That's why you don't have
I don't
kids.
care.
It's
I'm
like
not having
irresponsible.
kids.
So all right, that's a different conversation up here. So by 2050, scientists, think things are going to start happening. Like we're going to see bad things happen, climate change wise. So you're right. 300 years. I don't know. I don't think so will be extinct. I think
it will.
the world we know is going to look very different. All right, moving on. Easy to exploit. Now, coal is very useful here for this reason. Now, again, you're taking your own notes. I don't know what you're writing, but this is a good one. Coal, you don't need to really do anything with it. You can literally take it from the ground and throw it in your coal burning furnace. You don't really have to do anything with it. That's a big plus. Oil doesn't work that way. You got to refine it. Inexpensive because there's a lot of it, and it's not that easy, or it's fairly easy to get. And the easy to handle and transport kind of ties into refining. You just literally take it, put it in these giant carts or containers on railroad, for example, and bring it wherever you need to. And all our infrastructure is already geared up for this because we've been doing it for hundreds of years. Disadvantages, we've gone through those. The one thing I didn't tell you about, and I do have some things here, is the ash that is left behind. So I do want you to write this down. That's a big problem. These coal burning plants keep the ash. You can't just dump it in the ground because it has impurities and it's toxic essentially. So think of that mercury, arsenic that's left over. And there was a huge spill. Let's see, 2008 in Tennessee. 1.1 billion gallons of ash spilled over 300 acres. Took 5 years to clean and $1 billion. $1 billion to clean it up. So that's kind of the conversation we were just having. If you do everything right, not only does it pollutes the air, but if you do everything right, there's a lot of energy from coal. But if something happens, there you go, $1 billion, 300 acres, 5 years to clean that up. So the ash is what's left over after you burn it, is fairly toxic, so it's really bad for the environment. We already talked about all those. I feel like it's missing something here. No, that's about. Oh, yeah, one thing it didn't say. Write this down as well. Sometimes coal burning plants wash the coal first. So they have these chemicals that they soak or spray the coal in to kind of clean off some of the impurities. But that chemical they have to do something with, and that sometimes leaks. All right, so there's always, a trade-off we say in the class. There's always something you have to deal with. So if you clean the coal so it's not as bad, what do you do with the stuff you cleaned it with? So that's another negative. Okay, moving on. Petroleum and crude oil. There's another picture there. That's actually probably better than what I found. Oh, thank you very much. All right. Advantages of oil: convenient transport, relative energy dense, cleaner than coal. All right, we'll cover all that. We got all that. Disadvantage: releases CO2, leaks. 2010, BP, British Petroleum, lost 206 million gallons in the Gulf. We talked about that already. I'll just say it again. I just remember online there would just be live footage, and you could watch the oil just spewing out of the pipe. And I couldn't, for the life of me, understand why I couldn't just stop it. It was very difficult to go underwater and stop it. I get. If I remember correctly, some of it was freezing. You guys probably don't remember. You're pretty young.
Some really good duct tape.
So, yeah, I remember. I'm very simple. I'm like.
What's that Flex Seal?
Yeah, sometimes it's like that phrase, keep it simple, stupid. Like I'm like, why can't it just be a simple fix? But anyways, that was rough. There,
saw my photo.
right. Okay. Focus. Stay with me. You're doing a good job. I know there's a lot today. So there was 206 million gallons in the Gulf, but in other parts of the world there's bigger spills. I didn't write them down. So, but oil spills are a big problem. Runoff enters marine waterways. Also, sulfur, mercury, lead, arsenic in oil. There's also impurities in oil. Again, you're here taking care of your own notes, whatever you're going to write down, but you need to know the advantage, disadvantage of all these. All right. One thing I did want to mention is there's debate. The Arctic National Wildlife Refuge. There's apparently 378 billion gallons of oil underneath it, so people want to get it. How do you feel about that?
No, because it's rough though.
So it's already protected area, but there's talk of letting people drill.
No,
So,
we're literally ruining.
yeah, I mean, I think that's a terrible idea, but, you know,
It's a necessary
it,
evil.
well,
not.
it's
It's
not,
not
but it is
necessary.
the way policies, so I read something the other day, and this should resonate with you guys. Scientists and climate experts don't need to convince everybody climate change is happening and we should start using less fossil fuels. Who do they really need to convince?
The big companies.
Rich people, maybe.
Politicians.
The people that
The company
Company owners.
decisions.
make decisions and write
Laws.
policy and law. If you write policy and law, it doesn't matter what people believe, you have to follow it.
Yeah, but
So when I read that, or maybe I heard it, I get all my sources confused. That really actually made me feel good because I know people who don't believe it, and I can't be around them.
You want to
But
strangle them.
I can't talk about it. But the if you just think of it as if only the people who really make a difference in the changes they make, laws and policies buy in, then everyone will have to fall in, right?
Yeah,
So
but
that made me
those
feel
people,
good.
like,
That's a good thing.
voted into office by everyone else.
Right. So the people that are elected, it could be a vicious cycle. It depends.
You need
So-
the rich people though.
So-
You need the rich people to believe it. because they-
Yeah. Well, okay. We're not talking about solar yet, but Heliogen was started by Bill Gates. He's pretty rich. Okay, he's all about renewable. Elon Musk, pretty rich, all about renewable. So the rich people in the world aren't just fossil
Okay,
fuel
there's
people.
two rich
Yeah, it's
guys.
like two
Yeah, but
people.
they're
That's not the
ridiculously rich.
majority.
But like
So
everyone else,
I don't know about everyone else.
The people who
So-
run the companies are rich. The people who run the companies that are ruining the world are rich. Those are the
So,
people.
sure, the oil and gas companies, sure. Anyways, that just keep that in mind. All right, natural gas. One thing I did want to say here. Where am I? We already wrote that. Actually, we did that. We did that. Oh, one quick thing here about coal. Apparently coal is formed into liquids sometimes, and I did some research on it today, and it sounds like a terrible idea, and it's really expensive and produces more CO2. So I'll just admit, I don't know much about it. I'm not sure why it even exists. It seems really difficult to do and produces way more CO2 than just using coal itself. So I couldn't find out why. Why is this a thing that exists? I just figured I'd mention it to you. It's probably easier to use as a liquid. That's my only guess. Finish. Alright, last thing I'll end with this. Oh, you're gonna have homework. This is called the Hubert curve. I just read an article the other day online. This expert who works with politicians is a scientist on climate. He said that there isn't a peak oil. In other words, he says we're not going to reach a peak usage. Anyways,
What do you mean?
so there's arguments out there that we're going to run out of oil, we're going to run out of coal, so that's why we have to stop using them. Not because it's bad for the environment, because we're going to run out. He's saying that's not true.
I disagree
So, with what?
with that statement.
With what statement?
That we're not gonna reach a peak.